In this video, I'm going to show you how the Fibonacci sequence is moved around on the stack and in the registers when we do it with Recursive. We set fib_val is equal to 5, so we're going to find the fifth Fibonacci number. We have 0, 1, 2, 3, 4, and 5, so technically the sixth one. So when we have an unsigned int, we have a call in the stack, and we have n is equal to 5. And that does not pass either of our base cases. So we're first going to call the Fibonacci sequence to the left. So it's going to be n minus 1, which is 4. This is an important thing to bear in mind as you are working through and understanding recursion. We're going to go through the same process and allocate registers. We don't have either of them. And now we go to our first one. Go through the same process, F2. And then when we have 1, well, we find that this particular base case is met. So we return 1. So now here's the big thing that I want you to understand as you're trying to understand recursion. When we go back up to Fibonacci call 2, we've already called the left call, fib num n1. So now what we need to do is we're going to make the other call n2 as we see in the circle. We hit our base case, and we bring 1 and 1 up, and we now see on the right that n is equal to 2. Now we're going to go up to 3 because we've made that first call on the right. We've hit F1. We see that we hit our base case. We now have 2 plus 1 on the right, and it's now set equal to 3. Now we're going to go up to 4. Well, 4, we've already made the left call, so now we're going to make the right call. And we now have Fibonacci 2 on the stack. We go through this whole process again. We obtain both of the values. We go through that whole exact same redundant call. And I emphasize redundant because that's something we're going to cover in the next section on dynamic programming. So we have 3 plus 2, we get 5. And now we go up here, we've made the left call. So now we're going to make the right call with Fibonacci 3. And now we go through the same process. And what you're likely realizing is that we're doing a lot of redundant work. So we have 2 and plus 1, that becomes 3. Now this becomes 5 plus 3, and that is the end of the recursive trace, which means we have 1, 1, 2, 3, 5, and 8 is our solution.